Hi, everyone, and welcome back to the Intro to Quest video series. In this fourth section, I will be talking about how to use and manage software on Quest. The first thing that I wanted to mention is that you do not have admin or sudo privileges on Quest. What this means is you cannot install software in a system-wide manner. And if a software installation requires access to certain system directories, you might not be able to install it directly. This doesn't mean that you cannot install it, just not in a direct way that you might be able to on your personal computer, for example. There are multiple ways to get around this problem of not having sudo or admin privileges. And the first one is through local installation. This is where you install software to your home or projects directory, which you have access to. The next option is through modules. So this is where NUIT performs a system-wide software installations, and these are referred to as modules, which I'll talk a little more about in a later slide. And the third option is through virtual environments and containers. So this is installing through Anaconda or Singularity. Now, before we get into the three methods that I just mentioned, I wanted to note one thing, which is that you should avoid using system-level software at all costs. What this means is, so as a little bit of background, there are some default software packages installed in places like the directories that I listed here. For example, if you log into Quest and type which Python, so this is a command that asks Quest, which Python am I pointing to right now? It will tell you that it's pointing to user bin Python. And the same thing happens with Python 3. What I'm saying in this slide is that you should avoid using these specific software packages at all costs. Why should you avoid these? It's because these packages exist only to ensure the stability of Quest and are often extremely outdated. And also, there are only a bare minimum number of packages available in this way. This brings us back to the three options that we talked about in our previous slide. The first one was local installations to home or projects. How do you do this? It's often pretty simple to install software packages into your home directory in places like the directories that I listed here on the slide. The specific installation instructions will depend on the software package and can often be found on each software's website. In terms of when to use home versus projects, one advantage of installing it to projects can be that if you are hoping to ensure that everyone in your research group uses the same version of a given software, it might be helpful to install it to projects so that everyone's pointing to the same version of the software. If you do install the projects, though, make sure to add the path to that software into your path environment variable so that Quest knows what you're pointing to when you're using that software. The second option was modules. Now, you might be wondering, what exactly are modules? Modules are a library of centrally installed software packages that you can easily load or unload. Popular software packages like R, Python, Java, and MPI have several different versions packaged, and you can point to any one that you like. The reason why we need modules is that although we generally encourage users to install their own software packages, some packages are used by many users, such as ones like R and Python, for example. Modules allow system-wide installation of these popular software packages, but in a way that a user can pick and choose versions and what to make available in your own environment. A quick note here is that we always encourage users to specify the specific version of a module that you're loading rather than loading the default one. And I'll talk a little more about what this means exactly in the demonstration that I'll perform in a few slides. Before moving on to the third option, I wanted to introduce a few useful commands for managing modules. The first one is module avail, followed by a text pattern. This command allows you to see a list of available modules with this matching text pattern. The second one is module load, followed by the module name / the version of that module. This loads any given module and all of its dependencies. The third one is module purge all, and this command removes all loaded modules in your current environment. The fourth one is module list. This command allows you to see the list of all loaded modules. All right, let's move on to the next option, which is to install software in your Anaconda virtual environments. What exactly are Anaconda virtual environments? This is where you can create several isolated environments to which you can install different versions of Python and R packages tailored to the needs of each of your projects, or even each of the steps of your projects if needed. The advantages of this approach include the fact that you no longer need to worry about version conflicts because each environment they have is self-contained. You also no longer need to keep track of all the versions because Conda solves the dependencies for you. And lastly, it also has the advantage of reproducibility because once you create an Anaconda virtual environment, it can be exported into a file, which can be easily shared among your collaborators, and they can reproduce the Anaconda environment that you're working with. There's a lot that goes into Anaconda virtual environments, but we have several separate video tutorials on this topic. So if you're interested in learning more, please feel free to jump to those links through the QR code on the slide. All right, last but not least, you can also install and or use certain software packages through Singularity containers. What exactly are containers in the first place? These are just like virtual environments, but even more isolated and independent. It achieves this by virtualizing the operating system, but by using the same physical resources of the computer that you're on. The advantages of this approach include the fact that they're independent from the host operating system. So Anaconda virtual environments from the previous slide are still dependent on host OS, but by using Singularity containers, you can bypass this dependency on the host operating system. You will also have super user privileges within your Singularity containers, so you can install any packages that you like, even at the OS level. And of course, there's the advantage of reproducibility. One thing that I want to note here is that at the time of building the container, you will need super user privileges. So you will not be able to do this on Quest, but you can build them locally on your computer or on the Singularity Cloud Builder. During runtime, you will not need super user privileges. So if you have an already built container on Quest, you will be able to run it no problem. We also have a great YouTube tutorial on how to use Singularity on Quest. So if you're interested in learning more about using Singularity, please feel free to jump to that tutorial through the QR code on the slide. All right, so let's move on to live demonstrations. Here, I will be focusing on some of the tips that I talked about regarding modules. Here, I am connected to Quest through SSH on my terminal. If you recall, the command to see any currently loaded modules are module list. And we can see here that no modules are loaded in our current environment. Next, let's say we want to use Python. We can look for any Python modules with module avail Python. Now, after module avail can be any kind of text pattern. So we technically could do just Py, or we could do mini conda or something like that, but let's try out Python for now. We see that there are quite a few Python modules on Quest. And each item has the module name followed by a /, followed by the version name. You might notice that some of the versions have a parentheses D next to them, like this one right here. Let me explain what this means. So I mentioned in my slides that when you want to load a module, you can run module load, followed by the module name, followed by the version. Technically, you could load a module by only specifying the name, like module load Python. When you do this, the default version is loaded. And that default version is indicated by the parentheses D here in this case. However, we always encourage you to specify the version information when running module load. This is to ensure consistency because occasionally the default version might need to be changed. If you don't specify the version in your module load statement, this could lead to unexpected errors. So let's try loading one module. Module load Python Miniconda 3 4.12.0. Hit enter. Now when we run module list, we can see that Python Miniconda 3 4.12.0 is successfully loaded. If I want to remove this module from my environment, I can simply run module purge all. Now when we list our modules, we see that no modules are loaded in our environment. Now this concludes the 4th section of the Intro to Quest video series. Thanks again for watching, and I will see you in the next video.